Hi, ma'am.
Hi, Pranavi. Pranavi, you there?
Yes, ma'am, I am.
So, can you just brief about the working of AC generator, a simple generator? How does it work?
I'm sorry, could you repeat?
Can you brief about the working of AC generator? First, tell
Um,
me what is electromagnetic induction, and then how it is used to generate current by generator.
okay.
Hmm.
Ma'am, when a conductor is placed in a changing magnetic field,
Hmm.
the current is induced in the conductor.
Hmm.
Uh, this phenomenon where the current is induced is called electromagnetic induction.
Okay.
Um, and then AC generator, right?
Then,
You wanted me to explain about the AC generator?
yeah, generator. And how can we find the direction of induced current?
Ma'am, through the right hand Fleming's rule. Same as the left hand, but just with your right.
Hmm. Okay. Okay, that's fine. Let's begin writing about generator. First, you draw the diagram I'm sharing. We have two types of generator. The one which we discussed yesterday about, they had not the split rings but slip rings. Slip, okay, means the two sides of the coil, the two ends of coil was fixed to two different complete circular parts. That is slip.
Oh,
Means along with one, like side A, along with A, this complete ring R1 would be moving all the time, and with the end B, this complete ring B2 will be moving. So there will be no twisting, and that, like, the complete current will remain, will pass through the circuit, the electrical wire, this. And
ma'am,
because Hmm?
both the rings move in the same direction, and one of the end of the coil is in one. It's connected to R2, and the other end is connected to R1.
Hmm.
So won't they twist
No,
if
no, no.
they're going in different
If you do one
directions?
thing, you just draw the diagram. Today, working, I'll make you write so that it will become more clear to you.
Okay, ma'am.
You first draw the diagram, then I'll make you write.
Yes, ma'am.
Right from the beginning. A generator or dynamo is a machine
Generator.
generator or dynamo
Mm-hmm.
is a machine used for generating electric current by converting mechanical energy into electrical energy So first, this is AC generator. So, like introduction about AC generator is when a coil is rotated in a magnetic field.
Ma'am, 1 minute. Yeah.
When a coil is rotated in a magnetic field, comma, the magnetic flux linked with it, changes, and therefore an alternating EMF is induced in the coil, and therefore an alternating EMF is induced in the coil.
Yes, ma'am.
Next subheading is construction. Construction में first write field magnet. It is a strong permanent magnet. Basically, in the practical actual generators, the magnet, in this diagram it is shown the like perfect a cube like structure, but
Yeah.
the magnets are a bit curved, so you can name it
Wow. Like in the
horseshoe
video.
magnet so as to like focus the magnetic field in the across the coil. So you can
Okay,
add
ma'am.
it is a strong permanent magnet is fine, or it is a strong horseshoe magnet.
Okay, ma'am.
That's it. Next, armature. Armature. It is a soft iron core. It is a soft iron core on which a coil ABCD having large number of turns of insulated copper wire is wound full stop. The coil is rotated rapidly. In the magnetic field between the poles of the magnet.
Yeah.
Third is slip rings. The ends of armature, the ends of the coil are connected to two coaxial metallic slip rings R1 and R2, which rotate along with the coil. And the last in construction is brushes. Two brushes B1 and B2. Made of carbon. Press against the slip rings. Full stop. The external circuit is connected between the other ends of brushes. The external circuit is connected between the other ends of brushes. Full stop. The brushes B1 and B2 do not rotate along with the coil. The brushes B1 and B2 do not rotate along with the coil.
Yes, ma'am.
Okay. Let's start with the working now. Suppose that the coil ABCD.
What's the subheading?
No subheading, just we are starting the working.
Okay.
Suppose the coil ABCD is initially in the horizontal position. Full stop. Again, suppose that coil ABCD is being rotated in anti-clockwise direction. Again, suppose that coil ABCD is being rotated in anti-clockwise direction between poles N and S. Between poles N and S. Now point 1, because as the coil will start rotating, now we have to see the force acting on side AB and CD. Okay. So
Yeah.
first, anti-clockwise means Let's talk about the side AB only, Pranavi. Wait. Magnetic field is directed this direction, B, and AB is moved anti-clockwise, means AB is pushed downwards. Okay.
Yeah, the force goes down.
So please find the direction of induced current, magnetic field.
From A to B. So, ma'am, the induced current or the magnetic field?
Induced current, and if it is pushed downwards. So direction of current is?
From, wait. The magnetic field is this side. Like, and the force is down, so
Current
it
is?
goes towards me.
It was towards us. So do one
Yeah.
thing, because this diagram I have taken randomly. So just ignore these arrows. Okay.
Okay,
The
ma'am.
direction of current we'll be drawing according to us. Okay.
Okay, ma'am.
Don't draw these arrows. These are just showing current. None of this. So in the first, the direction of current is towards us, means B to A.
Yeah.
Okay. And similarly, in the first, means it has just started moving. So let's decide the current in CD also. Arm CD, it should be, CD is pushed upwards. So current is from D to C.
Yeah.
Let me write D to C. And this is B to A. It means in the circuit, it should be passing here from brush B1 to brush B2. This is our first cycle. Okay. So accordingly, we have to frame our sentences. As the coil rotates in anti-clockwise direction, start writing the first point of working.
Yeah.
As the coil rotates in anti-clockwise direction, the side AB moves down. At these points, Pranavi, very small. You can just write in the one, like in first half rotation, in side AB, on the side AB, so that it does not get too complicated in the diagram, actual diagram. Magnetic field is here, force is downwards. You can make it clear and spacious, okay? And the direction of current is this, so that later on when you have to revise, you remember it easily.
Draw the arrows in the first place.
Yeah. Separately, you can just draw arrows according to your convenience. This
Okay,
B
ma'am.
is for magnetic field direction, and this AB, I have written the name of the coil.
Okay, ma'am. Yes, ma'am.
Should I continue?
Yeah.
As the coil rotates in anti-clockwise direction, the side AB of coil moves down, cutting the magnetic field lines, and side CD moves up, cutting the field lines near South Pole, full stop. Due to this, induced current is produced. In sides AB and CD. Full stop. By Fleming's right-hand rule. By Fleming's right-hand rule, we find that by Fleming's right-hand rule, we find that currents are in the direction B to A, B to A, and D to C. B to A and D to C.
Yes, ma'am.
Just a minute. The side AB was pushed downwards and the current in AB was B to A. The side CD was pushed upwards and current in CD was D to C. So if we take the complete the paths of current, it will be continue writing. Thus, effective induced current is in the direction DCBA. Thus, the effective induced current is in the direction DCBA.
Yes, ma'am.
Fine. Now, second point means this is the case until the coil comes back and it completes half rotation. Means when CD will be on the left side and AB reaches the right side. Okay, after half rotation. After half revolution, sorry, the sides AB and DC, will interchange their positions. The sides AB and DC will interchange their positions. So AB starts moving up. This time AB will start moving upwards. And CD will, wait a minute. AB starts moving up and DC starts moving down. As a result, direction of induced current in each side of coil is reversed. As a result, the direction of induced current in each side is reversed. Yes, ma'am. Now further we can continue. Since the direction of induced current in the coil is reversed after half revolution, you can, hence the polarity of the two ends, with polarity in the bracket, you can write positive and negative. Hence the polarity, positive and negative, bracket close, of the two ends of the coil also changes after half revolution. Also changes after half revolution. Now should I write the direction of current again, or
I think it's fine. I understand.
Okay. Or we can just, in short, we can write if the AB is now up, the direction of current in AB would be, because AB will be pushed upwards, it will be A to B. This time the current will be A to B. You can write in your own language. Okay, this much means after this half revolution, direction of current is A to B, and in C DC side, it will be C to D. So the effective induced current will be this time A, B, C, D.
Ma'am, could you repeat the current again?
Current in
Current.
AB will be A to B, direction will be A to B. Earlier it was B to A, this time it will be A to B.
Mm-hmm.
Direction is C, in CD side will be C to D.
Okay, ma'am.
So the effective direction is A, B, C, D. So look at the coil. Earlier it was D, wait, D, C, B, A. This time it is A, B, C, D. So very clear
Yeah,
that polarity is changed.
it's changed.
This leads to the alternating induced current in the coil. This leads to alternating induced current in the coil. Not in the coil, in the load, you can say. You can write in the load, means this external circuit can also be called as load.
Right. Yes, ma'am, done.
In UAE also, I think the frequency is 50 hertz only.
Yeah, ma'am, I tried searching it up. Nothing actually came up like that. So,
Okay, fine. Just write a simple statement. I'll make you write in India. I hope that is fine.
yeah, no problem.
The alternating current produced in India, the alternating current produced in India has frequency 50 hertz, has frequency 50 hertz. That is, the coil is rotated. That is, the coil is rotated at the rate of 50 revolutions per second. At the rate of 50 revolutions per second.
Yes, ma'am.
That is, the current changes its direction. That is, the current changes its direction 2 into 50 equal 100 times. 2 into 50 equal 100 times.
That is so fast. Yes, ma'am.
That's all about AC generator, alternating current, and now DC. Fine. So yeah, you were asking earlier that want this wire, this coil get twisted.
Yeah.
Now see, if you have understood after working, these brushes are fixed. Okay, means
Yeah.
till this part
Hmm.
it is fixed, and the side A of the wire is connected to ring R1. Ring R1 is this, means ring and brush are not permanently connected. So along with the A, R1 will be completely moving at its place. R1 has no other connection except this side A.
Oh,
Whereas
okay.
this ring R2, that's why these are slip rings. These are not split. These earlier in motor, they were the part of same circle, the two semicircles, right?
Yeah. They were
And
just
this time
split.
the complete ring. That's why two different rings with the two
Okay.
different sides of coil.
Okay, ma'am. Yeah, understood.
Or right. DC generator also. In DC, we use split rings only instead of slip rings.
Okay, so only in the AC generator you use slip ring.
Slip. I want to show you. Okay, this because it will take so much of time writing the DC generator. I'll make you write and show you one video also. Now almost a chapter is except domestic circuit it is completed, so we can practice more questions. Which chapter is started in school, Pranati?
They finished almost the human eye, so they'll probably start electricity or magnetic effect later.
Wait. Can you speak again, please?
Ma'am, they almost finished the human eye.
Okay.
They're on the last parts of it, so.
So the first chapter you took is human eye and not.
No, ma'am, light is already finished. We already had one set of exams before this, so
Oh,
light
okay.
is finished.
Okay. Then light and human eye. Any idea about your midterm exams?
Yeah, only light and human eye for physics.
Okay, fine. Now we can solve few questions that we left that day. Start from the 12th, Pranavi.
A rectangular loop carrying a current I is situated near a long straight wire, such that the wire is parallel to one of the sides. If steady current is created in the wire as shown below, then the loop will remain stationary. It's not moving here and there, so the loop will remain stationary.
Yeah, means because no magnetic field or no induced current will, no change in magnetic field, so no current will be induced, so no such effect. It will be stationary.
Yeah.
13.
The direction of the induced current in an electric conductor when placed in a whirling magnetic. Fleming's right hand rule.
14.
The two coils in a non-conducting cylindrical rod. Um, Ma'am B.
There are two coils mounted on conducting cylindrical rod. Initially, the key is not inserted. Then the key is inserted and later removed.
Wait, there are momentary. The galvanometer. No, ma'am, the closest is B because both the times where it's inserted and put out, removed, then the galvanometer will show difference, right?
So B or D?
Ma'am, it doesn't show all the times of B.
Dear, but the galvanometer shows momentary deflection in opposite directions. First when it was inserted, next when it was removed.
But ma'am, that basically is saying that throughout that they'll be showing momentary deflections, right? It's only when the key is removed and put in that it shows deflection.
No, why you are getting confused? See, when we inserted the key, the current value rose to from 0 to certain value. When we
Yeah.
removed the key, the value of current again reduced back to 0. So magnetic field first strength increased, then decreased. So two opposite direction will be shown by the galvanometer, right?
Yeah.
And not only in the case when it was removed, when it was inserted, then also. So option D would be correct.
Okay, ma'am.
15th we did.
Oh, yeah, we did.
It's
Uh,
a huh?
yeah, no, we didn't do that. Fleming's right hand, no, we didn't do it.
Hmm. Assertion reasoning.
Uh, hmm, the magnetic field is stronger at a point which is near to the conductor. Um, Ma'am, assertion and reason is true, and reason is the correct explanation.
Correct. 17.
A current carrying conductor experiences force in a magnetic field. The force acting on a current carrying conductor in the magnetic field is due to interaction between the magnetic field. Ma'am, both A and R are true, and R is the correct explanation.
Fine, correct. 18.
If an electron moving vertically from outer space enters the Earth's magnetic field, and then it gets deflected towards the west. Um, okay, from outer space and use the magnetic. So, ma'am, then the current would be the opposite direction, right?
Yeah.
We take the positive
Hmm.
charge.
The direction of current should be taken. If it is mentioned vertically from outer space, then you have to assume the opposite of this vertical.
So, ma'am, how will the force be?
How's the?
Which direction is the force?
Wait. If an electron moving vertically. The force central magnetic field into the Earth's magnetic field, then it was deflected towards west. Vertically from outer space. Magnetic field is north to south. So we have even that it is going behind. Magnetic field is this. And current we should assume going outer space. Then I think it should come towards us.
That's right.
Magnetic field is north to south. So assuming the four directions in front of our eyes, north, south, east, west. Magnetic field is north to south. First finger should point downwards. Force. No, current should be. Okay, this is something in which direction we should actually consider the direction of current.
So, downwards. If
Of
it's downwards, then the magnetic field goes from me to the screen, and the force goes from the left to the right.
vertically from outer space. From my side, it is fine. Okay, leave this question for a while. Let me think that where to take the current.
Okay, ma'am. The magnetic field.
Can you just do one thing, you draw the diagram of DC generator, and if you can write the working of DC. Wait, let me show you. Or else I'll share this worksheet. You can practice the remaining questions from this worksheet only. Okay.
Okay, ma'am.
Fine. Bye.
Bye, ma'am. Thank you.